Powered Parachute Handbook 11.2 Approaches and Landings. Let's delve into the intricacies of wing control, a critical aspect of the landing phase. The application of flare is intricately linked to the extension of the pilot's legs. To execute a 1/3 flare, extend the steering controls approximately 1/3 of your leg length. For a full flare, fully extend your legs, and for a half flare, push the controls out half of your leg extension, and so forth. This measured input ensures a nuanced and controlled response. The amount of flare required during landings correlates directly with the descent rate. A steeper and faster descent demands more flare input for a smooth landing, as the flare converts forward momentum into lift. During landings, the ideal flare should be a single, fluid motion, akin to a rhythmic 1, 2, 3 sequence. The precise amount of flare needed depends on the rate of descent just before landing. In instances of a very gradual descent, minimal flare is necessary, while an engine-out descent, the steepest descent for a PPC, requires a full flare. The smooth execution of the flare is instrumental in the transition from descent to a gentle touchdown. The touchdown itself is the graceful settling of the powered parachute onto the landing surface. Both the roundout and touchdown should occur with the engine slightly below level flight power levels. As the powered parachute descends, the parachute is flared to ensure a smooth and controlled landing. It's crucial to note that forcing or attempting to land without flaring can compromise the landing quality. The paradox lies in the fact that an optimal landing is achieved by holding the powered parachute's wheels a few inches off the ground for as long as possible. Flare is a deliberate action accomplished by simultaneously pushing both steering bar tubes, pulling down the entire trailing edge of the parachute. This increases drag, lowers forward speed, and, crucially, enhances the lift of the parachute. The amount of flare required is contingent on the rate of descent just before landing. If the descent is gradual, minimal flare suffices, while a rapid engine-out descent demands a more substantial flare. The precise judgment of flare intensity is honed through practice, with a general guideline suggesting the initiation of flare 1 second before the anticipated ground contact. Notably, flare is favored over engine power for its responsiveness in controlling descent and pitch. When flare is applied, the increased drag on the wing prompts a rapid response, rotating the wing backward and adjusting its pitch angle. Contrastingly, achieving the same effect with engine power involves throttle adjustments, propeller acceleration, and thrust that can affect the heavier cart, making flare the more effective control measure. Finally, the touchdown must occur with the powered parachute's longitudinal axis precisely parallel to its direction of movement along the surface. This alignment is crucial to avoid imposing side loads on the landing gear, emphasizing the importance of preventing drifting during touchdown to mitigate side stresses. Certainly, let me provide you with a continuous text without headings and numbering. The information in this chapter pertains specifically to powered parachute land class operations. For details regarding powered parachute Category C-class aircraft, refer to the Seaplane, Skiplane, and Float, Ski-Equipped Helicopter Operations Handbook, FAA 8083-23. A normal approach and landing involve standard procedures for typical situations, considering factors such as available engine power, wind conditions, absence of obstacles in the final approach, and a firm, level landing surface. The selected landing point should be beyond the runway's approach threshold but within the first 1/3 portion of the landing area. To better understand the factors influencing judgment and procedures during the approach pattern and landing, these phases are divided into 5. The base leg, final approach, roundout, touchdown, and the after landing roll. The manufacturer's recommendations in the Pilot's Operating Handbook, PO, take precedence over the information in this chapter. The base leg's placement is crucial, requiring accurate judgment of altitude and distance for a gradual descent. Drift correction should be established, maintaining a ground track perpendicular to the runway centerline. The final approach aligns the powered parachute with the runway centerline, making slight adjustments in power to control the descent. The descent angle is influenced by throttle adjustments and wind conditions. The roundout is a smooth transition from normal approach descent to landing descent, gradually leveling the flight path a few inches above the runway. Visual cues and depth perception play a role in executing a successful roundout. During the roundout, the flare is initiated by applying gradual power to decrease the descent rate. The amount of flare depends on the rate of descent, and visual cues help in determining the appropriate timing. Flare is crucial for a gentle touchdown, converting forward momentum into lift. Wing control during the flare is directly related to the pilot's leg extension, with the amount of flare linked to the descent rate. The touchdown involves a gentle settling onto the landing surface, with the powered parachute's longitudinal axis parallel to the direction of movement. The landing process is incomplete until the powered parachute stops completely, the engine is shut down, and the wing is collapsed and secured on the ground. After landing, tasks include releasing the flare, closing the throttle, shutting down the ignition system, and collapsing the parachute. Crosswind landings are feasible, but taking off in crosswinds may not be possible. A wide runway may allow for landing across it, but on a narrow runway, landing directly into the wind is essential. In the case of a crosswind landing, crab into the wind during the final approach, align with the runway centerline, execute the flare, reduce power upon back wheel touchdown, shut down the engine, and promptly bring the canopy down to the ground.